Welcome to our last video for this lesson. We are going to find a general formula for sequences, arithmetic sequences, when we are given only partial information. So rather than a list of numbers, for this first example, A, we have been given the common difference and the first term. So when we have the common difference and first term, it's very straightforward to just plug these into our equation. AN equals A1 plus D times n minus 1. So we have AN is equal to 2 plus 3 times n minus 1. Simplifying, we have 2 plus 3n minus 3. And so our final answer would be AN is equal to 3n minus 1. Other times, however, we're given incomplete information without either the first term or the common difference. So this example B is one such example. We're given the second term and the fifth term. Now, remember that arithmetic sequences are linear, and so we can use the slope formula to calculate our common difference. So our slope formula is m equals y2 minus y1 over x2 minus x1. When we're looking for a common difference, we're going to have our common difference, and then we're going to have an sub 2 minus an sub 1 divided by n2 minus n1. This looks a lot more challenging than it needs to, because what I'm going to do is I'm going to take our second one, 30 minus 9, and then I'm going to have 5 minus 2. And so 30 minus 9 is 21, 5 minus 2 is 3, and 21 divided by 3 is 7. So now we have our common difference is equal to 7. We still need to find our first term. So let's recall that our general form is AN equals A1 plus D times n minus 1. And we know something about two terms. So I'm going to arbitrarily pick this term up here. And so here, when n is equal to 2, AN is equal to A sub 2, which is equal to 9. So I can plug in 9 on the left side, 7 here for D, and 2 for n. So 2 minus 1 is just 1. So we have 9 equals A1 plus 7. If I subtract 7 from both sides, because this is 1, I get 2 is equal to A1. So what we're able to do now is, let me go back to our first color, green. AN is equal to 2 plus 7 times n minus 1. And I can distribute once more to get 2 plus 7n minus 7. And then finally, combining like terms, AN is equal to 2. Nope, I need to combine my like terms. So AN is going to be equal to 7n minus 5. And that gives us our rule. I do want to do just a couple more examples. So find a general rule for each sequence. In this case, for C, notice that we have already been given our common difference. So we just need to find our first term. So AN is equal to A1 plus D times n minus 1. We know that when n is equal to 4, an, or a4, is equal to 35. So we can plug in 35 on the left side equals a1 plus 8 is our common difference, 4 minus 1. So 8 times 3 is 24. So we have a1 plus 24 is equal to 35. If I subtract 24 from both sides, 35 minus 24 is 11. We get over here, a1 is equal to 11. I shouldn't really box that in. It's not our final answer. But I am going to change color so that we can distinguish our work. So we have now an is equal to our first term plus our common difference 8 times n minus 1. Now I can distribute, so we'll have 11 plus 8n minus 8. And so finally, an is equal to 8n, and 11 minus 8 is going to be 3. So plus 3. That gives us our explicit rule or general formula for the sequence. Lastly, we have another example where we have incomplete information and we'll need to use our slope formula. So let's pick a color I haven't used yet. How about this grayish color? So D, our slope, is going to be 65 minus 20. That's the numbers I'm underlining. And then putting a dot beside the other two numbers that go on the bottom, 13 minus 4. So 65 minus 20 is going to be 45. 13 minus 4 is 9, and 45 divided by 9 is 5. So our common difference is 5. Now we can use either term to help us find our first term using an is equal to our first term plus our common difference times n minus 1. But it's generally going to be easier to use the first term where we have a smaller value of n. So 20 is equal to a1 plus 5 times 4 minus 1. 4 minus 1 is 3. So 20 equals a1. That is a very absurdly long plus sign. So 5 times 3 is 15. If I subtract 15 from both sides, I have 5 is equal to a1. And so over here, an is going to be equal to 5 plus 5 times n minus 1. Distribute, we get 5n minus 5. Combine like terms, we get an is equal to just 5n. So our sequence is given by a very straightforward expression. It's equal to 5n. And so with that, we have wrapped up our lesson. There is additional practice, which I will have uploaded solutions for in a PDF on GoFormative. And then finally, graded homework as well. So make sure you do the practice and the graded homework. Sooner is always better when learning new skills. The more immediately you can practice and then review and practice some more, the more you will develop and deepen your understanding and your knowledge.